Let's take a look and analyze some of the best prototypes from the FRC rebuild season so far. Now, this does come down to the question of whether your team should consider using turrets or whether it should consider using a more fixed shooter in this design. I'm Coach Pratt, and I've been teaching robotics design for over a decade now. And today we're going to take a look at some different spindexer designs that are showing some promise, take a look at some really in-depth behind-the-scenes footage of how your team might design a turret, and talk about whether you might actually want to use a turret in your design or not. And we'll also take a look at some successful different shooter prototypes and climbing prototypes for the rebuild season. So first up, we've got a couple prototypes here from Jagbots 4638. They've got a single compliant wheel here on some cardboard and tape systems. Now this is running on tennis balls, not running on fuel. So it's interesting to see whether this is going to have the same amount of translation in fuel performance, but it is capable of whipping around a lot of tennis balls around quite quickly on just a single compliant wheel. Now they do a follow-up here with the same fuel running a couple dual systems here. And I'm curious on if they're not seeing the same success on their system here because they have such a high friction surface on the end here. So they are using foam tiles on the edge. And the thing about using foam tiles is that has significantly more friction on those fuels and those game pieces than the cardboard and tape system did. So that may be part of the reason why this isn't performing as well. Could also be the tolerances of the amount of curve around. So as a quick prototype, I think it works well. Something to consider is you may want to make a little not quite so low fidelity on the low fidelity prototypes running this. I mean, same thing with, using a piece of the Andy mark. What is this? I believe that this is, they call it the churro for that as well. It is shaking around a bunch, perhaps getting a second point on in that sort of rapid prototyping phase. Next up here, we've got a spindexer here from Hammerheads 5000. I think this is a really interesting way of being able to corral some of the fuel around in that effectively what it is it's a bit of a curved hook that as it is spinning around inside that sort of central point, that ball is able to move its way up into that slide and then up through the center point to then launch itself up into that turret or shooter mechanism, depending on what it is they have. It's a great way of centralizing things around as well as indexing them to be able to get them into a reliable point. Because the whole point of these spindexers is that you want to have a reliable output. So you can take a game piece from one section and it always has to move it to the same piece wherever your outtake is in a reliable fashion to the same place every time. So that's the most important thing on these spindexers here. If you are not taking that fuel and moving it to a reliable exit location every time, you've really not done a good job of indexing. Next up here, we've got a little bit of driver practice here from Critical Circuits. I think it's going to be, well, as all FRC games typically are, coming down to good driver practice is going to be a big one. Particularly this season where you have a lot of shared elements of fuel, where you have, several hundred pieces of fuel that are shared across a couple teams. Having a lot of driver practice is going to be important, and especially because you have multiple alliances on the same side while a single hub is active. Being able to move those things around is going to be a really big deal this season. So make sure you're leaving yourself several weeks or at least a week of driver practice to give yourself the best success moving into your tournaments. Next up here, we've got a bit of a turret series here from Team 4481, the Rembrandts. I really like the Rembrandts in that they are, they're part of the Open Alliance and they do a great job of sharing out a lot of their designs here. So they've got what they're affectionately calling their washing machine with some brushes on the side to be able to push this around. And then this is also capable of funneling it up and into their turret mechanism. Now, the turret mechanism looks like it's not very effective right now. However, they go in a little further onto this turret mechanism a little bit later, where we can actually see their first shooter test shots. It looks like they're using a herringbone gear with an adjustable hood that is able to move itself up so that as you get closer, you can change the angle of the hood. As you move farther away, you can change the angle of that hood as well, so that you can end up with some different tolerances on that as well. It looks like they've got a pretty consistent high throughput. The thing about their turret here that I continue to like is that they're so open about sharing how it is that the design actually works. So we can see the internal mechanism of that large gear on the outside here. As well, they show off there a hard stop on a turret mechanism, because I think this is one thing that a lot of teams may not think about. You can have a limit switch here. You could have a Hall effect sensor on here. You're like a magnetic sensor effectively, so you know when your turret has reached that last point. Particularly if you're not using a slip ring, this is a good way of having a hard mechanical stop so you don't rip yourself out. Now, this does come down to the question of whether your team should consider using turrets or whether it should consider using a more fixed shooter in this design. I think it's going to come down to what your drive base is. If your drive base is swerve, using a turret may not be all that useful because you're already capable of rotating your robot driving around and moving in single directions. If you're using a mechanism chassis or something like that, not as common in FRC, but there are teams that do use mechanism chassis, you are capable of driving around in omnidirectional movement, so you don't have to be focusing directly on that hub. If you are using a tank-style drive, you may want to consider something like a rotating turret because you're not going to be able to rotate your robot to face that so easily. So if you want to have a little bit higher defense on a tank, that might be the way to go with a rotating turret, whereas adding in an additional degree of freedom with a turret may not be worth that extra complexity, or the juice may not be worth the squeeze, so to speak, in that respect. So it's something to think about as you're getting about midway through your build season here, and you might be thinking about, critical design pivots and whether you're going to move down to an idea or not. Something to think about in that respect. Let's talk a little bit about shooters here. We've got the FRC Team 3255 here showing off a double shooter. Now, if you look at their shooter here, they actually have a piece of either acetyl polycarbonate, some sort of plastic in the middle that is actually funneling those two fuels into their two separate shooters. I think it goes to show just how effective a dual shooter can be at having far higher throughput. Because again, this season is going to make or break on having a high throughput of getting a lot of fuel quickly into your robot, a lot of fuel out quickly into your robot. I like what we've done down the bottom here. They have a first set of wheels to initially pick up the speed on that fuel before it reaches to the flywheel, so you don't have to have this large sort of smack on that. You kind of already have some initial momentum built up on that fuel before it actually gets into that shooter. And I do think teams that have I've also seen this before in some, they have a single bar that goes all the way across. And you have multiple fuel game pieces going through a shooter at once. Having either an extremely high throughput on a single base shooter versus, a mostly high throughput on a dual shooter. It seems to me like a dual shooter seems to be outperforming a single shooter at this point. Now, as things start to align, a great thing here down from Littleton Robotics from 6328, we can see they've got, their drum-based shooter here. They can get a really high throughput through this. And again, high throughputs are really, in my opinion, what's going to end up winning for teams this season. And then last up here, we've got a couple different climb designs. I want to share some from Critical Circuits here. Now, they did mention in their notes here that they didn't expect this to work, but they wanted to try it anyways. For teams that are considering having really large cantilevered sections here, there's just simply not, the center of mass is just way off here, obviously, to be able to lift yourself up off of one point. Potentially, if you were able to have a fully clamped bar around, there is potential that system might work. However, I think you're still going to run into just so much torque on this single lift system that it might not be able to work so well. Actually, I think this is actually bending their steel plate as it moves as well. So there's a lot of torque on some of these robots, particularly with their heavier motors, heavy battery packs, things like that. Now we've got another prototype here from 4458. And they've got a pneumatic climber as well, which seems to be working pretty well. That's not a prototype that I've been seeing some teams use before up to this point by using pneumatics to be able to lift themselves up. But it's an interesting way of achieving that climb, as well as a way that climb can then lift itself back off after. I think that's something that you need to be focusing on with your climb, is to be able to lift yourself up to the first rung and then bring yourself back down again later. And the last up here, we've got team from 4731 here, and they have a nice kind of passive claw system here run up on a few springs. So it's allowing itself to drive up and underneath a bar in such a way that it can move out of the way and then continue to climb on. So typically you have a hand over hand climb. Saw this a lot in the FTC into the deep season. I've been seeing some teams start to prototype this up as well. And I think it's a really efficient way of taking yourself into that 30-inch height requirement for this season as well. They've decided to run these on sort of some linear slides as sort of a carriage-based system. where they have some large aluminum extrusion on the side, and then they have some ball bearings on the side that are clamping it onto that system as well. Then typically use some sort of belt or chain to be able to actually drive this system up and down if it's fixed onto one unit as it rotates. It looks as though somebody's just rotating this by hand right now, just to do some quick testing. But I do think that a ball bearing carriage system is a really successful way of being able to do some of these climbs. So I'm curious what your team is doing for their strategy. Let me know in the comments down below and how that's going now that you're about midway through the traditional build season for FRC. If you're looking for more robotics resources, you can consider joining my community below. And if you have something interesting that you think the community would like to see on FRC for Rebuilt, I've got a submission form down below that I can take a look at and share out with the community. As always, best of luck out there this season.